Hi guys, today we're working with the remainder theorem and reviewing polynomial division methods, the box, also known as the area model, long division, and synthetic division. So the remainder theorem basically states if we plug a number into a polynomial, what we get out is the remainder. So if we have f of 6 equals 3x to the third plus 4, whoops, sorry, not paying attention, 3 times 6 to the third plus 4 times 6 squared minus 59 times 6 minus 20. Then we evaluate that. First we do exponents, so 3 times 216 plus 4, 6 squared is 36, then minus 59 times 6 minus 20. You can also put all of this in the calculator, but I do like to have the work shown so you understand where it comes from. 3 times 216 is 648. 4 times 36 is 144. 59 times 6 is 354. And minus 20. And then we can plop all that in the calculator. 648 plus 144 minus 354 minus 20. And that gives us 418. Now, this is our remainder. When we divide that polynomial, so when we divide this polynomial by x minus 6, we would get a remainder of 418, which means that this is not, that x equals 6 is not a root of this polynomial, so it's not an x-intercept. I'm going to scooch this up a little bit to confirm this with another method, and I'm going to use the area model method for a couple reasons, because main reason being it's the most obvious, let me state that again. It's the least obvious of the three methods. So using the area model, we take the factor x minus 6 if it has a root at x equals 6, which we know it does not, but we want to confirm our answer here. And we are going to put the first term in the lower left box, factor out the 3x squared, because we know that x times 3x squared gives us 3x to the third. Then we multiply 3x squared times negative 6 to get negative 18x squared. We know that our x squared needs to be 4x squared, so 4x squared minus a negative 18x squared is going to give us 22x squared. Factor out the 22x. Multiply 22x times negative 6. And we get negative 132x. We know that our x term here is needing to add to something to get negative 59x. So negative 59x minus negative 32. 132 is a positive 73x. Factor out a 73. And we multiply that by negative 6 to get negative 438. And this is where the remainder isn't obvious, because we know that negative 438 plus something is supposed to equal this last term of negative 20. So we can make that equal to negative 20. Negative 20 plus 418. Negative 20 plus 438 is going to give us 418, which matches that remainder from the remainder theorem. So that's how we confirm that with the area model. What I'm going to do now is show you the same polynomial checked with different roots with all four methods. So remainder theorem will be first, and it's important to remember with the remainder theorem that you use the root and not the factor. So we're using just x equals 4, so f of 4. And I took you through that whole process, so I'm going to pause it and do all the work. So when we plug the 4 in, we do all of our exponents first. 4 to the third is 64, 4 to the second is 16. Do all our multiplication, and then add everything up, and we end up getting 0. What that 0 tells us is that y equals 0 when we put 4 in for x, which means that, yes, x equals 4 is a root of this polynomial. And therefore, so it has a factor of x minus 4. And you guys are kind of used to that in parentheses. If we go back from the remainder theorem. So another method for that is the area model. And we want to make sure to use the factor and not the root. So when we do that, x minus 4, so 3x to the third, factor out 3x squared, multiply negative 12x squared. 4x squared minus negative 12x squared is 16x squared. Factor out 16x. 16 times negative 4 is negative 64x. Negative 59x minus 64x, and I'm getting that from up here. So negative 59x minus 64x is 5x. Factor out of 5, multiply to get negative 20. Because this number matches that number, then we know that, yes, x equals 4 is a root. That confirms our answer from, because we have no remainder to get to negative 20. Just FYI, for your upcoming test, you do need to be able to take that and factor it, so you can fully factor it and find the roots. You can go back to some previous videos for that. I would go back to a ways back now that I think about it. I don't have the reference point for you, but box and diamond to factor that one if that's your method. Okay, next one is long division, which I don't mean to be writing in red, so I'm going to change that in a moment. This uses the factor as well, and mathematically it's the same process as the area model. So 3x to the third plus 4x squared minus 59x minus 20. Divide that by x minus 4. So we want to see how many times x goes into 3x to the third. So what do we multiply by? And we get 2x to the second. No, we don't. We get 3x to the second. Multiply 3x to the second by x, and we'll put that there, and then 3x to the second times negative 4, and we'll put that there. So 3x to the third minus 12x to the second, and we're going to subtract. Because we're subtracting everything in that parentheses, the 3x's to the third is 0. 4x squared minus a negative 12 is the same as adding, so we've got 16x squared. And then we drop down that minus 59. Oops. That 16x squared should look familiar from the area model. And then we do the same process again. Figure out how many times x goes into 16x squared. So we factor, we multiply, we subtract. We factor, we multiply, subtract. So that's 16x. 16x times x is 16x squared. 16x times negative 4 is negative 64x. So then we're at subtract again. 59x minus a negative 64 is positive 5x, which should also look familiar from the previous page. Drop down the minus 20. X goes into 5x 5 times, so plus 5. So that's the factor part. Multiply again. 5 times x is 5x. 5 times negative 4 is negative 20. subtract, and we get 0 for a remainder. So once again, we are confirming, yes, x equals 4 is a root. Last method is synthetic division. So this one you have to be careful with. You're just using your coefficients, and you have to make sure that your exponents are going from largest to smallest, 3, 2, 1, and 0, and that they are also not missing any, because then you have to use 0 as a coefficient in that place. So we've got 3, 4, negative 59, negative 20. Oh, by the way, synthetic. And this uses the root, not the factor. So this uses the root of 4. So you leave yourself a space, drop down the 3, multiply 4 times 3, you get 12, and you add to get 16, 4 times 16 to get 64, you add again, negative 59 plus 64 gives us 5, multiply 4 times 5 to get 20, and we end up with a remainder of 0. So once again, yep, x equals 4 is a root. So those are the 3 different methods. I'm going to take our step here and factor this fully so that you do see that. 3x squared plus 16x plus 5. Part of the problem was x minus 1 more. Can't use synthetic division with this because you need to make sure you need to have a root, and we don't have any more roots. So we're going to use the box and diamond method, or the area model, just smaller version. It's 3x squared, 5. First and last terms get multiplied together to give you your top term. Factor your top term, 1 and 15. 15 is not divisible by 2. 3 and 5, and it's not divisible by 4, so we're back to 5 and 3. 16x is our middle term, so that goes on the bottom. 1 and 5 is the pair that adds together to give us 16. So I'm going to put those in the remaining boxes. Sorry, 1 and 15, if I said 1 and 5. So when you factor, you have to be careful, because if you just look at this row, when you're looking at the 3x squared, you can take a 3x and a 1x to divide out of those, but you can only take 1x out of this row to put here because 1 is not divisible by 3. You have to take the 3x out the bottom because 15 and 3 are both divisible by 3. So you take the 3x out here, times x gives us 3x squared, times 5 gives us 15x, and then x times 1 gives you 1x, and then you double check that 1 times 5 gives you 5. So you have it in fully factored form. So that is our original, so that's our first factor from the last page, x plus 5 and 3x plus 1, and this should technically all be f of x equals. So what that means is that we have roots at, this is using the zero product properties. People try to flip it without thinking about it. X minus 4 equals 0, so x equals 4. X plus 5 equals 0, so x equals negative 5. And then people tend to jump on this last one, 3x plus 1 equals 0. People tend to go, oh, it's negative 1, and it's not. You have to make sure to actually set it to 0. I'm going to do that up top. So 3x minus or plus 1 equals 0, subtract 1. So we have 3x equals negative 1. Divide by 3. So you have x equals negative 1/3. So that last root is x equals negative 1/3. So you need to be careful with that one and make sure that you are able to find that root when it's not just a coefficient of 1. So next thing you need to know is what's up for your test. Basic polynomial graphs. This was AA3-2, basic polynomial equations, was also AA3-2. Exact was AA3-3. Fully factoring high degree polynomials, that was AA3-5 and AA3-6, using the remainder theorem and then confirming it with one or all three polynomial division methods. You are allowed one side of one 8.5 by 11 or smaller sheet of paper for notes, and that cannot be in a worksheet. And it needs to be handwritten. So there it is. I have a practice one for you to do. I'm not going to do it on the video, but this is something that you might look at for highly proficient, figure out different ways to fully factor. When I say consider your available resources, you might look at Desmos to see if you can find one of your roots, and then go from there. So that is it for kind of summing up the remainder theorem, the different methods of polynomial division, and fully factoring, which will be the new things on your next test. Have a good one.